Now we're going to take a look at how to multiply radicals. Now there's a couple of different options for these. One is to just multiply the numbers under the radical and then simplify. I like to keep my numbers as small as possible, so I actually simplify before I multiply. Now looking at A, the square root of 6 cannot be simplified. There's no perfect square factor, and same for 14. But if I look at the factor trees, I notice that together they have a pair of 2's. 2 times 2 is 4, the square root of which is 2. So anytime you find a pair, you pull that number out, and then you multiply what's left under the radical. 3 times 7 is 21, not 27. Now I'm not sure what steps I have listed here, so let's look at the process that I gave you. Determine what factors the numbers have in common. Okay, so that's what I did. I did the factor trees, and they had a factor of 2 in common. So any pairs come outside the radical, that was the 2, and then everything left was multiplied. Let's look at that process again with part B. So doing the factor tree, I'm actually only going to do the factor tree on 30 because I know that 15 is a factor of 30. Now granted, 15 is not prime, but that doesn't matter. It's a common factor. So I've got 15 listed twice as my list of factors. So 15 will come outside the radical, and what's left is 2, so that stays under the radical. All right, on part C, we've got some coefficients to our radicals, so here's how that works. Those numbers just stay outside the radical, and the rest of the process is the same. So I'm going to do my factor tree for 8 and 10. Now I have a pair of 2's here, but I have another pair of 2's, one on each tree. So here's what's coming outside. First of all, I had my 3 times negative 2 that were already on the outside, and I had 2 pairs of 2's. So one from each pair comes out, and then what's left staying under the radical. Multiplying everything together, I've got negative 8 times 3 is negative 24 times the square root of 5. Last piece of information, we're going to look at how to add and subtract radicals. So the first thing that we do is simplify each radical separately. Unfortunately, because we're adding, we cannot add them if they are not like terms. So we have to get the number under the radical to be the same, kind of like when you have to find a common denominator before you can add and subtract fractions. So perfect square factor of 8 is 4, square root of 4 is 2, and what's left over is 2. In case you can't follow my train of thought, what I am doing is 4 times 2 gives me 8, square root of 4 comes out of the radical, and the 2 stays under. So for 50, 25 times 2, square root of 25 is 5, 2 stays under the radical. Alright, so that was my step 1. Step 2, add or subtract the coefficients if the number left under the radical is the same. Had I gotten 2 times the square root of 2 plus 5 times the square root of 3, that would be done. We couldn't simplify it any further. It's like trying to combine x plus y. You can't do that. I think that might be my last step. So 2 plus 5 gives me 7, square root of 2. And similar to adding or subtracting fractions where you leave the common denominator alone, or when you add x plus x, you get 2x, you leave the x alone. We leave the radical alone, so we don't change what's under the radical. Last example, perfect square factor of 48 is 16, because 16 times 3 gives me 48. Maybe I'll kind of show my work up here. So the square root of 16 is 4, 3 stays under the radical. 27 is 9 times 3, square root of 9 is 3, and the 3 stays under the radical. Subtracting my coefficients, 4 minus 3 is 1, so I'm just left with the square root of 3. And a couple of you try again. If you can't see them all, find them on my website on the PDF for today's notes.